In my previous video, I showed you how to do one sample t-test in SPSS, and in this video, I'm going to show you how to do t-tests for when you've gathered two samples and you want to compare them against each other. It's not any more difficult to do the analyses, but you have to know a bit about experimental design. So I can gather my samples in different ways, and I'll stick with my previous example of intelligence, and I'll say I'm interested in whether the IQ scores of college graduates are different than the IQ scores of people who did not graduate from college. So I'll gather my samples in different ways. One way would be to compare the IQ scores of a group of college graduates against a group of different people who are similar to the first group of college graduates, except that this group did not graduate from college. The term for this comparison is independent samples. Another way I can gather my samples would be to compare the IQ scores of people before they went to college to the IQ scores of those same people after they went to college. So in this case, I only have one group, and I'm measuring them multiple times. The term for this type of comparison is paired samples. So I'll start with paired samples. And here are some fictitious data of people's IQ scores before and after they went to college. And I'm quickly going to label those scores so I don't forget what they are. Say pre-college IQ, post-college IQ. And I'll make that nice to read. So, the organization of these data is very important. The design is called paired samples because they're paired in a very certain way. This person's pre-college IQ score needs to be right next to that same person's post-college IQ score. They have to be right next to each other, otherwise the results won't be accurate. So this is one person's pre-college IQ score and their post. This is another person's pre-college IQ score and that same person's post-college IQ score, and so forth and so on. So set it up the right way. Now once the data are in there, doing the test is pretty simple. Just go to Analyze, Compare Means, and pick Paired Samples t-test. When this window pops up, just move over the variables you want to compare. So we want to compare pre-college IQ to post-college IQ. You can select each variable and move it over. And when you're ready, hit OK. Now a few tables should be popping up in the output. So when they do, let's take a look at them. The first table is just the descriptive stats for each variable. It has the mean, the sample size, the standard deviation, and the standard error for each variable, for pre-college IQ and for post-college IQ. Right below that in the second table, we see the correlation coefficient between the two variables. We don't really need this, but you would use the correlation coefficient if you were actually calculating this t-test by hand. So SPSS seems to think you'd want it for some reason here, but we really don't need it. The third table has our inferential stats, so that's the more interesting thing we want to look at. On the far right, we see the t-value, degrees of freedom, and the p-value that corresponds to that t-score at those degrees of freedom. And as before, for the p-value, we want something small, like less than 0.05. This p-value does happen to be less than 0.05, so we can conclude there is a significant difference between people's pre-college IQ scores and their post-college IQ scores. What is the significant difference? There are several ways to determine that. For one, we can just look at the means. That's probably the easiest way to do it. And it shows us that the post-college IQ scores are slightly higher than people's pre-college IQ scores. So we can conclude people's IQ scores are significantly higher after they go to college than before. Another way to interpret the difference is to look at this box in the third table. It says mean. This tells us the difference between these two means, simple subtraction. If it's negative, that means that mean 2 is bigger than mean 1. And we can see that's the case. Mean 2 is bigger than mean 1. We can also look at the sign of the t-score, which is going to be the same as the sign of the difference between means. But I tend to focus less on the mean difference in the t-score, because which variable we call mean 1 and mean 2 is arbitrary. So let me show you what I mean. I'm going to go back to Analyze, back to Compare Means, back to Paired Samples t-test. We can move these means over in any order we want. So if I hit Reset, I can move post-college IQ over first and then pre-college IQ. If I want to switch it, I can just highlight the comparison and there's a little button down here lets me switch them back and forth. So when I rerun the analysis and it's switched with post-college IQ scores as variable 1, pre-college IQ scores as variable 2, I get exactly the same results, the same means, same standard deviation, same correlation coefficient, even the same p-value. The only difference is the mean is now miraculously, the difference is positive. So is the t-score. It's positive instead of negative. So basically, you don't need to really focus on whether the sign is positive or negative because the order you pop them in is arbitrary. The last thing I want to show you are the confidence intervals. This little box here in the middle tells us what kind of difference we might expect to see in the population. Now, I talked about this briefly in the previous video, but basically you should always remember you're dealing with samples. We don't know what the true difference in mean IQ of all college graduates in the world versus all non-college graduates in the world. But this confidence interval gives us an idea about what it might be based on that sample. Basically, it says we're 95% certain that post-college IQ is at least 0.38 points higher than pre-college IQ, and at most it's about 9.22 points higher than the pre-college IQ. If you can do the same thing if the means are different, but you just interpret it backwards. So getting back up here to when pre-college IQ was mean 1 and post-college IQ was mean 2. It's telling us that the upper limit we'd see is pre-college IQ scores being 0.38 points lower than post-college IQ scores, and the lower limit is pre-college IQ scores are going to be 9.22 points lower than post-college IQ. And either way you do it, whichever one is mean 1, whichever one is mean 2, the true difference between means is likely somewhere between these two values. We just don't know exactly what it is. We're 95% certain it's somewhere between these two values. If one value is negative and the other value is positive, it's kind of like saying we don't know if post-college IQ scores are higher or lower than pre-college IQ scores. And that's another way of saying that there's no significant difference. So that's how we do paired samples t-tests in SPSS and how we interpret the confidence intervals. In the next video, I'm going to show you how to do the t-tests for the other experimental design, independent samples t-tests.